not knowing the primary identity and then the two that follow with cosecants and secants and all that, it's going to make the proofs pretty difficult. Just about every single identity involves one of those two. Just about. Okay, show your neighbor. Make sure you've got them right. Which is good, Anthony. At the same time, make sure you can derive them, okay?
I'll make them equal to 1, right?
No. No. They shouldn't equal 1. Because when okay, it could. But when you do the substitution, it's not going to be that easy. Yeah.
So for the unit circle, we had to just like know them off the top.
You got to know those 3. I'm giving you nothing.
Is it? I understand that, but is it okay if you take the time to?
Yeah, I don't care. I don't care. Derive them. Do whatever you want. I'm not giving them to you. So you get them however you want. Derive them. Memorize them. Of course, I prefer you derive, but whatever. Just make sure you know them, like where the subtractions are, which ones go together. All right. So I don't have a red marker. Huh. The red marker seems to have gone bye-bye. All right, here we go. Give me the number 1 identity. Okay, there are a lot of variations, right? We went through and we did like 9, 10, 11, however many there were. What's the next? Involves secants, cosecants, whatever. There are 2. Give me one of them. Yeah, Glenda. Yes, and I like that Glenda says beta after all of them. That's good. One more. Yes. And then from there, you can manipulate. You can subtract cotangent squared. You can subtract 1, do all kinds of difference of 2 squares, etc. Okay, so Ryan, we're going to go back to you. What did you say about some kind of substitution?
You can substitute 1 in cosecant squared and minus tangent squared.
Okay, so Ryan says, let's substitute that the secant squared of v is 1 minus, what is it, tangent?
No,
1.
Substitute 1 in for the secant squared. If you
Oh, yeah. Ryan's totally correct. Yeah. Yep. That's a variation of one of the 3 identities. It's a variation of the 3rd one on our list. So secant squared v minus tangent squared v is 1. I'm not going to continue to rewrite it. You may have teachers in the future. Hold on, Josh. You may have teachers in the future who make you write it all down. I don't. Be grateful that you don't have to rewrite it. Yeah, Josh. Yeah. Okay. I've got to turn that into sine plus cosine. Yeah, Ishika. Fantastic. So tangent sine over cosine. Secant over. So I'm not going to write 1. What should I write instead?
Well, if you separate those two, like from the 1 plus tangent b, or the secant b, if you separate that goes to 1.
Yeah, that works. Yes, that gets you to the right place. Absolutely, you can do it that way. I'll explain what Ryan said in just a minute. I'm going to write 1 as cosine over cosine. This is Algebra 2 Honors, those complex fractions that you don't like. They have a common denominator of, what do I have I have a cosine of v as my common denominator. So, multiply numerator and denominator by the cosine of v. But you do not have to show this step. So you're left with cosine v plus sine v over 1. Right-hand side. The very last step, you must have the two equal to each other. You can't just do the whole, okay? The very last step must be the same. Is this okay?
Yeah.
Totally. It's addition. What? Done. Okay, so I'm going to show you how Ryan did it, which is great little method. So Ryan took it from 1 plus tangent b, and some of you may have done this as well. I just don't know because you're not sitting in the front row. So I just rewrote from here to here to take you what he did next. Okay, so Ryan, can you say what you did?
So 1 over, well, I technically transformed like the 1 into tangent b into sine b over cosine b. I just did it and then
So you did the tangent was sine over cosine?
Well, I kind of did that.
That's not what you told me you did.
Well,
Ryan separated your answer. Ryan separated it into two fractions. 1 over secant, last I checked, is cosine. And then tangent over secant is sine. How is that possible? Tangent is sine over cosine over secant, which is 1 over cosine, which is sine. Yeah, that works very well. Is it legal to do this whole thing here? Yeah, it's totally legal. It's totally legal. So, a little side note of how to avoid voodoo. Plus b over c. A binomial over a monomial, yes? This is the same thing as a over c. Right? Other way around does not work. C over a plus b does not equal c over a plus c over b. Okay, not the same. Okay? Alright, so let's do one that's harder. I haven't done it yet, so hopefully it works out for us. We're going to struggle through it. I hope you'll do it with me. Let's do number... I don't like that one. Okay, we're going to do this. This is number 94, if you care. The ones in tonight's homework tend to be a bit harder than the ones that were due today. So, if you care to pay attention... What do we know about alpha and beta? Do we know what those letters represent? What? They're variables. Alpha and beta are Greek variables used quite a bit in trig. Okay, so my alphas don't look, I can't make them the way the book makes them, but there's your alpha, and there's your beta. It's more like a fat A. But I don't draw them very well. Lots of people say it looks like goldfish, but that's not really what it's supposed to look like. It looks like a fat lowercase a. Actually, it just looks like a lowercase a with a little, like, thingy on it. I don't know. Okay, anyway, there are great alphas in the book. That's what my alpha looks like. It's not fantastic. We'll, okay. Tangent alpha plus tangent of beta. Tangent alpha plus... You could, but you should get used to the Greek. Greek is cool. You're learning alpha. That's not so hard. You do it already.
Those are letters, not words.
Okay. Well, I guess you're right. I mean, alpha is it's a letter, right? A is not a word. C is not a word. D E F G H I. J is a word. I is a word. J K L. Q is a word. Is Q a word? Oh yeah. Absolutely, Q is a word.
What do you mean? How is Q a word?
Q.
It's like you're in the queue waiting, like when you're on the call.
That's not one letter.
Yeah, if you spell it out.
Right, but J. Okay, so J. This is how you spell the letter J, and it happens to be a word. Actually, all letters can be spelled. Like the letter F is spelled EFF. Oh my Lord. Let's continue.
Like, how is that a word?
Be nice, Risha. Be nice.
Ouch.
All right, let's get back to some.
More time on dating on my paper.
Do you have it written down right? Okay, now this is important. If I have it written down wrong, we're going to have a hard time. Tangent alpha plus tangent beta times the quantity 1 minus cotangent alpha cotangent beta plus the quantity cotangent alpha plus cotangent beta times the quantity 1 minus tangent alpha tangent beta, and we're going to make sure that equals 0.
So this is like the second alpha looks exactly like the word of the book.
Okay, great. Let's move on. From alphas and betas. Well, start me on the problem. Okay. I haven't done it before. I'm starting at, obviously I'm going to start on the left. If I were doing this problem by myself, I gave you the problem, it's on a quiz, where are you going to start? Yeah, Ashwin. You mean you want to change the tangents to sines and cosines? Okay, so let's try it. Make sure you're using a pencil. It may or may not work. I don't know. Let's try. So the tangent is sine over cosine. The tangent is sine over cosine. Make sure you're keeping your alphas as alphas and your betas as betas because they are not the same. They might be, but chances are they're not the same. What do you want me to do with the 1, Ashwin? You want me to just leave it as 1, or you want me to try and get a common denominator now? What would you think? You don't know? Okay, so you know what I'm going to do? I'm going to leave a little space so we can convert the 1 in a little bit. Not quite sure what I want it to be yet. Cotangent. Cosine over sine times cosine over sine. Okay, keep going. Write it all out. No, actually. Yeah, sort of. Yes, I am. Sort of. What number is this? 94.
Sort of.
Okay, so you get cotangent cosine over sine plus cosine over sine I'm going to write the equal 0. We can handle writing equal 0. I left space. I don't know what to do with the 1. Ethan. Like right in front of you, their laptop open. Ashwin spoke up first, and Ashwin said, let's do it this way. It's a place to start. So what am I going to do with the 1? How do you want me to write this 1 and that 1?
It doesn't really matter. You can just leave it at 1. Leave it as 1, and then you just multiply everything and just reduce and multiply everything by 1. And it cancels. Reduces.
Okay, so a bunch of you are saying it doesn't matter, but if I want a common denominator down the road...
Well, if it's 1, you just know it's 1.
Correct. And then this is cosine alpha. I'm not leaving enough room. You can obviously see how messy this is. What would you recommend? I don't know. I'm just asking. You started. Not sure? Okay. Okay. Yes. I would agree with that. If one of these quantities is 0, the whole thing is 0. And if one of these quantities are 0, the whole thing is 0. 0 plus 0 would be 0. Or they can equal different numbers, yeah. Don't wait for me. Talk to your neighbor. Figure it out. I'm not taking the quiz for you.
Could you just multiply it out using sine of alpha times sine of beta and then subtract?
You can't use the right side, though.
No, like inside the parentheses. Like you already have the common denominator.
Add subtract. So this is like not a common denominator. Here we have a common denominator. Good. Try. Yeah. Without your laptop. Oh my lord. So, what do we think? What do we think? You could multiply it out, but it wouldn't be fun. You could multiply it out. Yeah, I'm not going to multiply that out. That's going to be like sine squared alpha cosine squared beta times cosine alpha cosine beta times the tan. What should I do? Yeah, Glenda. Common denominator is cosine alpha cosine beta. So I'm going to multiply by cosine beta over cosine beta. And this gets multiplied by cosine of alpha times cosine of alpha. So now I've got a common denominator of cosine alpha cosine beta. Cosine alpha cosine beta. And then I can add. And I get sine cosine plus sine cosine all over blah. JC, did you have your hand up? Okay. Ashwin? It'd be nice, but you can't. So I'm going to recommend We take a different path.
Oh, do you know the answer?
No, I don't. I mean, I looked and it's like, I can't look at it that fast and follow. I'm doing this problem on my own. Well, it needs to be 0 equals 0. Yes, that's the whole point. So, X, I do. I think you have to start somewhere. The issue is, if I'm looking to multiply that all out, it's just so. If I'm going to multiply it all out, why don't I just start multiplying it all out from the beginning? Ishika says we have to multiply it out because none of the properties that we know so far, they all involve squares. There's no squares here. All right, go for it. Multiply it all out. Absolutely. Absolutely. You do identities in pencil, you try. And you know what? Like literally, I've half done the problem. I intentionally don't do them ahead of time on purpose so that we can like figure out the struggle together. And you can see that I can do a lot of them quickly, but not all of them. Well, exactly. If there weren't alphas and betas, it'd be so much nicer. Well, then change them. Or change to X and Y. There's no problem with that. I heard some great mathematical language there. Make sure you're writing this down right. Earth is this helping us. I'm not done yet.
Cotangent alpha times tangent alpha is not 1.
No, it's not. Cotangent alpha.
Tangent alpha.
Oh, I thought you said alpha beta. Yes, you are correct. I thought you said alpha and beta. If you made a mistake with the alphas and the betas and the cotangents and the tangents, like how on earth is this nicer? Because you probably didn't hear it said cotangent alpha times tangent of alpha is 1. Cotangent alpha times tangent of alpha is 1. Cotangent beta times the tangent 1. Tangent alpha, cotangent alpha, 1. Tangent beta, cotangent beta, 1. Yeah, things just got a lot easier. How is that possible? Because tangent is sine over cosine. Cotangent is cosine over sine, blah, blah, 1. Yes? So do the next step. Did you get it? Bless you. It's a lot to keep track of. That's exactly. You have to be so careful with the. I believe this is. You tell me. What's the next line? Wait. Tangent of alpha minus. Yeah, minus cotangent of beta. Beta minus the cotangent of alpha plus the cotangent of alpha. Holy guacamole. What's the next one? Minus the tangent of beta plus cotangent of beta. How about minus tangent of alpha? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. No. 7.
There should be 0 like minus.
Okay, can you follow along for me? Tangent of alpha. Let's see if that's what you have.
Yeah.
Minus cotangent beta
Yeah.
plus tangent beta
Yeah.
minus cotangent alpha
Yeah.
plus cotangent alpha
Yeah.
minus tangent of beta. I'm asking you to look at yours and follow along because someone said I'm missing.
There should be minus plus cotangent beta.
Well, this is minus tangent of alpha, but you're telling me, what am I missing?
It works.
1, 2, 3, 4, 5, 6, 7.
You forgot. There's a cotangent beta
I
times 1
multiplied the
that you
cosine
forgot to multiply out, like alpha at the top.
Okay, so tangent, cotangent,
Obviously it's faster.
tangent,
Yeah, you
cotangent.
missed a step up there too, like from the first line to the second line.
From here to here?
Yeah, but it's in the second term. There's a cotangent beta times 1
It
over there on the right
really
side.
wasn't bad.
Here?
No.
Thank you. That would just be easier. Please show me.
Right here. You forgot to put that.
Thank
I think
you.
just skipped it.
Thank you. Okay. Yeah, it's much easier just to show me that way. Thank you. Boom, boom, plus cotangent beta minus the tangent of beta minus the tangent of alpha. Okay, tell me that works. Tangent alpha, that looks like something else. Tangent of alpha minus the tangent of alpha minus cotangent beta plus cotangent beta plus tangent of beta minus tangent of beta. Boom, boom, boom.
I had one.
So you still didn't even use the
It didn't, other than sine over cosine. Yeah, Sam? I missed like one of them or two of them, so you may be missing one as well. That one's long, but it's actually only a two-step identity. It's just a lot of writing. Yeah.
On the homework, I got problems down to sine squared beta plus cosine squared beta equals 1.
So 1 equals 1. You have to write 1 equals. Yes, you have to write 1 equals 1. All right, let's try another one. Let's try one more. Let's do, I don't want to do it, that's going to take the entire period. How about, oh, that one's super long. That one's like six lines long in the book. 84. No, 84 is a big one.
We should do 93.
No.
We should.
80, 84, 90, 94. There's a couple, but yeah, the problem is they take 15, 20 minutes. I said 96, yes? Oh yeah, this one's got a mixture of alphas and betas and everything else too. Oh my. All it is different variables. If you prefer, write x and y. It doesn't really matter. Sine alpha minus cosine beta squared. Plus cosine beta plus sine of alpha 90 times the cosine of beta. I did not leave myself enough room. Minus the sine of alpha. I'm out of room. Negative 2 cosine of beta times sine alpha minus cosine beta. Sorry. The right-hand side says negative 2 cosine of beta times the quantity sine alpha minus cosine beta. It's hard to read. I wrote sideways. All right, what do we think? Yeah, I'd multiply everything out as well. Alpha minus 2. Thank you. Absolutely. Absolutely. Should be 2 sine. Yeah, these are not squared. The first one is. Yes, yes, yes. Plus. Oh, it's a factored out difference of 2 squares. This is a factored out difference of 2 squares. Oh, I see it. No, I don't see it. Yeah, I kind of see it. I kind of. Keep it in parentheses. If it's not being FOILed? Oh, it doesn't matter. Help me out here. I can factor out what? Yep, and that's negative. And factor out a cosine beta, and it's negative. So, this one's pretty basic. That leaves you with sine alpha minus cosine beta. Okay, so just a little heads up. All the ones that we did today, I do not consider these to be that difficult. Sarah. Here to here, sine squared minus sine squared is gone. Have negative sine alpha. This is 2 cosine squared beta. So I factored out a cosine. Yeah. Yeah, absolutely. It's good to ask. So these, I think, are very realistic. Be a little bit messy as you're going through, but the actual proof is not so bad. All right, so we have a couple of minutes. I want you to take out your homework, and I want you to work with something near you to see if they can help you with what you may have been stuck on. Tangent. Thank you.
Homework survey about?
No idea. My guess is how much homework you're getting. You're welcome. All right. The homework to the people behind you. Anthony. Name, pass it up. I have more homework to pass back, but I'm going to wait and do it tomorrow because the bell's going to ring. The identity, page 476. Pass that up. Thank you.
Is tough. It's pretty good. Teaching it well. I'm not a
It's not about teaching. This has honestly got nothing to do with how I teach it. It is 100% to do with just perseverance. See you later.
Thank you.
We did, yes. Put the books back still to pass back.